This video is on isomers. These are different types of isomers. We have stereoisomers, optical isomers, and I'll jump down to geometric isomers. And the ones we're going to be concerned about are only two, and really structural isomers and conformational, we're not going to deal with. We'll mention it a couple of times, okay? Um, but we're not really interested. When we say isomers, we're talking about structural isomers. That's the only one you have to worry about in here. And so what a structural isomer is, a structural isomer, it is defined as having the same formula but a different structure. And that means the connectivity is different. Okay, so let's look at one. Let's take C4H10, which you know as butane. That's the formula for butane, but it's also a formula for a different compound. So we can write this as CH3CH2, CH2, CH3, that's our butane. And that has this structure right here. 1, 2, 3, 4. That's our line structure. And I can do another formula, CH3, CH3, and put a CH3 coming off here because carbon can bond to itself. Notice I have two carbon-carbon bonds here, one right here and one right there, and actually a third one to this single carbon here in the middle. Okay, so there are three carbon bonds here. On this side over on the left, we only have at most two carbons to any other carbon. And so this is a different structure, and we would draw this like this and put a line up there. And so I would have a carbon here, 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 and here, four carbons. Notice the N carbons all have CH3 because they're N carbons. There are always going to be CH3s out here. And this one, this time, is a CH because we have one less bond available. We can only put one hydrogen because there's already 1, 2, 3 bonds, so only one hydrogen can fit on that carbon there. Okay? That's a little different than what we did. So this is a structural isomer. Now, to still sticking with our butane, let's look. This is what's called a conformational isomer. Notice this has CH3 on the left. We have CH3 bonded to CH2, bonded to CH2, bonded to CH3. Down here, we have the same thing. We have CH3 bonded to CH2, bonded to CH2, bonded to CH3. And so we've rotated around one of these bonds right here. In fact, we've rotated about this bond. And so these freely rotate in and out. And so this is actually exactly the same molecule. It's just folded in on itself. And we can't control that. These tumble and turn and rotate around these bonds. Okay? And so this is conformational. Conformational isomers are the same compound. We're never going to worry about them except right here. So what we're interested in is structural isomers. So let's give a couple. Let's look at C7H. Let's see, we want an alkane, so it'll be 14, 15, 16 times 7 times 2 plus 2, C7H16. And so here's one isomer. 1, 2, 3, 4, 5, 6, 7. This is not an isomer. 1, 2, 3, 4, 5, 6, 7. That is a conformational isomer, which we're not worrying about. It is not a structural isomer. So we'll put a big X through that. How about this thing? 1, 2, 3, 4, 5, 6, 7. That is a structural isomer. You can follow the connectivity Over here I have 1, 2, 3, 4, 5, 6, 7. Over here my longest chain, 1, 2, 3, 4, 5, 6, and then I have this piece over here hanging off it for my seventh carbon. So this is actually a different structure. How about this thing? 5, 6, 7. This is the same molecule. And how you figure this out, this one and this one are the same. How you figure this out is find the longest chain. 1, 2, 3, 4, 5, 6. That was the same as over here. 1, 2, 3, 4, 5, 6. And then I have my piece out here. So this is just rotated, okay? Rotated. And you can make them look like that. In fact, these three are going to be the same. This one's going to be the same. 1, 2, 3, 4, 5, 6. That just made my bond angles funny, but it's exactly the same. So this one, and this one would be called conformational isomers, which we're not going to worry about. I don't even know if they call these two conformational. This is a structural isomer to all of these. How about this thing? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That would be slightly different than the one we had before. 5, 6, 7. Those are different because this one's on carbon 1, 2, 3, 4. This one's on 1, 2, 3, 4, 5, 6. So that's how you can do it. There's my seventh carbon, and this one, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7 is 1, 2, 3, 4, 5, 6, seventh carbon. Okay, are there any other structural isomers of this thing? Think about it for a minute and then look at what I show you here. Okay, I've drawn a bunch of these. Some of them are structural isomers, some not. The way to do this is count. 1, 1, 2, 3, 4, 5, 6, 7. That's going to be different than any of these up here at the top. Okay, because I got one coming off 2 and 4. How about this one? 1, 2, 3, 4, 5, 6, 7. And so I have coming off 2 and 3, I have a carbon, a CH3 group. Gonna make my numbers a little more neater. How about this one? Now I got to get the longest chain. That's how to do this. So I start 1, 2, 3, 4, 5, 6, 7. That's coming off 3. Did I do one coming off 3 yet? Nope, that's different. So that's different than this one coming off 5, coming off 4. Oh, that one's coming off 3. Look at it up here in the top. 1, 2, 3. So you always got to start counting. You got to watch that. So 3, 4, 5, 6. That matches this one I just did. 1, 1, 2, 3, and we have it coming off 3 up here. Number 7 comes off 3 up at the top here, and number 7 comes off 3. So these two are the same. Be very careful with this. How about this one? We have 1, 2, 3, 4, 5. Can we count a different way? We can do 1, 2, 3, 4, 5. Yeah, this is all very similar here. And so this will be a different, I don't think we have one with 2 coming off 3. 1, 2, looking down here. 1, 2, 3, 4, 5, 6, 7. So I took a CH2 here and a CH3 here. So this can get confusing. How about this one? 1, 2, 3, 4, 5. I have 2 groups coming off now, 2 and 3. So 1, 2, 3, 4, 5, and then I get two groups, 1, 2, 3, 4, 5, and I have two groups coming off my second carbon. 1, 2, 3, 4, 5. I got two groups coming off my third carbon. 1, 2, 3, 4. I got two groups coming off my second, one off the third, and then 1, 2, 3, 4. This is the same molecule. These two are the same. So anything that's different is a structural isomer. If they're the same, you have to count differently in that. Then they're conformational isomers, and we don't call them isomers. They're the same molecule. Okay. So all we need to do is look for structural isomers. That's it.